Good afternoon, grade 12s. Welcome to Technical Mathematics. Today we are going to be discussing analytical geometry. That is the topic that we are going to be discussing today. But first, before we can start our lesson, just want to advise our technical mathematics learners, please use previous question paper when you are revising for this coming final exam. It's going to help you a lot to do well at the end of the exam. And then also you must have examination guideline just to go through that document. And then in every topic that we are doing under technical mathematics is under that document. Just go through that document and look, because there is information that you need to know for each and every topic that you do under technical mathematics. Please go and get that document, and then also the previous question paper, and then prepare yourself thoroughly for this coming final exam for technical mathematics. All right, now let's start and see what are we going to be discussing under analytical geometry. Under content, let's see what we have under content. Analytical geometry, it contributes 25 plus or minus 3 marks for paper 2. Remember, this topic you'll get in paper 2. So under analytical geometry, we are going to be looking at linear analytical geometry. We then move to cycle analytical geometry, and the last one is ellipse. But today, focus is only on the first two subtopic, which is the linear analytical geometry as well as the cycle analytical geometry. All right, now let us make sure that we revise everything under analytical geometry before we go and write our first paper for final, which is paper 2, and make sure that we do very well. And then remember, this topic is not that difficult. You will see when we are going to be discussing the questions on how you should answer questions under analytical geometry. You see, you will understand, and then you will find that majority of the formula that we are using, they are there on the formula sheet. So we just have to know when to use which formula. So that is very, very important. All right, and then let's start and see what are we going to be discussing. All right, we have different type of formula that we normally use under analytical geometry, but I did not write the names. I just you to remember them by just looking at them. Let me start with the first one. Let me just indicate. Let's start with this one. AB. When you're calculating the distance between the 2 points, for instance, if you have to calculate the distance between A and B, so this is the formula to calculate the distance formula there. You can just put B here minus XA, and then here you can just YB minus YA, or it's fine even if you can start with XA minus XB, YA minus YB, still fine. All right, and then the second one, when we are calling the midpoint, this is the formula for the midpoint. And then the third one, when we are calculating the gradient of 2 points, and then this is the standard equation for calculating the equation of a straight line or a tangent. And then this one is when you're calculating the angle of inclination, where you have tan theta equals to the gradient. All right. And then this one is when you are having two lines which are perpendicular to each other. For instance, AB is perpendicular to CD, and therefore, if that is the case, the product of these two gradients, they give us -1. And then the last one is when you just ignore this one, just ignore this one, so just a typing error there. And then in this one, when you have two lines which are perpendicular, parallel, AB is parallel to CD, what is happening? You must know that the gradient of the first line, which is AB, equals to the gradient of the second line, which is CD, when they're talking about the parallel lines. All right. So those are the formula that we are going to be using them and to answer questions. But the fortunate part of this is that they are all in the formula sheet. You just have to know when to use each formula that you see in the screen. All right. Let's see what we are going to be calculating in this one. All right. C. They're saying C, a point of x-intercept x exists. A is to -5, and then -3, and B is to 4 and 12. The vertices of the triangle AB intersect x exists at E. A angle BC equals to theta and B angle EC equals to alpha. Calculate the gradient of AB. And for us to be able to calculate the gradient, we need 2 points. Yes, we have A and B. And then let's just calculate the gradient. You write the correct formula, you substitute correctly. And then when you press your calculator, it gives us positive 5/3. That is the gradient of line AB. And then number 2, determine the coordinates of E. The coordinates of E. We can all see that these coordinates of E is the x-intercept, right? And then we all know that y is 0 at this point. So now we say we need to determine the equation of line AB. Now first, we need to determine the equation of this line AB, so that we can now be able to calculate or determine the coordinates of point E. And then you just substitute the values. And then remember, when you are calculating the equation of this line, of this straight line, we need 2 things. We need the gradient and the point. Now, remember, we've just determined the gradient of this point AB, which is 5/3. And then point, you can take point B, you can take point A, either one is fine. Then we have decided to take point B in this case. Then we're going to open the bracket with this 5/3. And then it's going to give us 5/3x minus 20/3. Then this -12, we then transpose it to the right hand side, and you see it's positive there, it's +12. Then from there you press your calculator, then this is the equation of that line. But as we are saying that that point E, the point is the x-intercept, we know that y is 0 there. So you're going to let y equals to 0, and thereafter where you see y, you just subtract with 0, then you transpose, and then you divide with 5, then the answer equals to the x value of that point is -16/5, meaning the point E is -16/5 is to 0. So that is the coordinate. So these are the coordinates. So you'll find that majority of people, the majority of learners, what they normally do when these questions say determine the coordinate of E, they will only just write, they will just only solve the value of x and leave your answer at this stage. But now you should write the point. Show that point E is -16/5 is to 0. That is the coordinates, all right? We're still in the same scenario, same structure, but now we need to determine what? We need to determine the size of alpha, and then round on the answer to the nearest whole number. Now, how do we determine this angle here? What are we going to be in need of is the gradient of that line, which is AB. And then the gradient of that line is 5/3. And from there you divide with tan, then it's going to be alpha equals to shift tan 5/3, then it gives us 59 degrees. So that angle is 59 degrees. All right. And then that is all. Well, we have answered everything under this question. And then let's proceed. All right, in the diagram, below, A is -4 is to 8, and then B is 1 is to -4, are points in the Cartesian plane. All right. C is the y-intercept of line of the line. And then now let's see what are we going to be answering. The first, we need to calculate the distance of line AB. Now let's calculate the distance of line AB. All right, that is the distance formula. A equals to, remember earlier on we were also discussing around the distance formula, right? And this is the distance formula. Then from there you're going to substitute the values xa, x minus xb, ya minus yb. Then from there you press your calculator. Then it's going to give us the distance of that line AB as 13 units. All right. And then number 2, determine the gradient of AB. Now let's determine the gradient. And then make sure that you take the correct formula for the gradient. Then you must substitute correctly. Now remember this one is 8 minus 4. Hence we are having positive there. And then from there our answer is negative 12 over 5. Our answer is negative 12 over 5. Number 3, determine the size of theta, the angle of inclination of AB, and round off to your answer to 1 decimal place. Now remember, if you're in need of that angle, which is angle theta, we need the gradient of that line, which is AB, and the gradient is negative 12 over 5. And then every time when you calculate the angle and then you find that the gradient is negative, then we always add with plus 180 there, so that it gives us the real the actual the actual angle. Because if you don't put this 180, the answer I think is going to be negative angle which is less than 90, and that is not correct, because you can see this angle is greater than 90, and then it's between 90 and 180. So hence every time when you are calculating the gradient, not the gradient but the angle, and then you find the gradient is negative, you must always add with positive 180 there, and the real angle there is 112.6 degrees. All right, now let's answer other questions. All right, we still have the same scenario and the diagram. And then now we need to answer the following questions. Determine the equation of the line AB. Now, let's first remember, when you have to calculate the equation of a straight line, we need two things. We need the gradient of that line and also a point. But you can see that we're having point A and B. You choose any point you want to use. And then in this case, we decided to use point B. And then remember the gradient of that line, it was negative 12 over 5. Then you write the standard formula, you substitute correctly. Then from there, you're going to open that bracket with the negative 12 over 5. And then this is what you're going to be having. And then this positive 4, you transpose it to the right, it's going to be negative. You just press your calculator. Then the equation of that line AB is negative 12 over 5x minus 8 over 5. Number 2, determine the coordinates of the point C. We all see that point C is y-intercept, and it's also given from the scenario there that point C is y-intercept of the line. Now remember, if y-intercept, we're in need of y-intercept, you let x to be 0, and then where you see x, then we are going to be substituted with 0. You can see this that, and then the y-intercept that we are looking for is negative 8 over 5. But now in the question was very clear to us and say coordinates of point C. Now, what are the coordinates of point C? These are the coordinates of point C, which is 0 is to negative 8 over 5. All right. In the diagram below, triangle ABC has a vertical A is to 6 over is to 6 is to 4, B -2 is to 2, C 6 is to -2 in the Cartesian plane. The angle of inclination of BC is theta. Then determine the coordinate of midpoint D of AC. So there is a midpoint, there is a point that we are looking for here, which is point D, the midpoint of AC. Now let's calculate the midpoint of AC, and then you just substitute them correctly, and then from there you have the midpoint as 6 is to 1. So those are the coordinates of what? Point D. So point D is somewhere here. And therefore, determine the equation of a straight line DB. Remember, we have this B, and then D is somewhere here is the midpoint of AC, and then we just determine the coordinates of that, which is 1 is to 1 is to 6, 6 is to 1, I mean 6 is to 1, and then determine the equation of that line. We need to call it the gradient first, the gradient of ABD. YB we can see is 2, and then YD is is positive 1, so hence is -1, -2, -6. So that is the gradient. That is the gradient of DB, and then now we then write the standard equation for straight line. Now you can choose whether you use point B or point D to determine the equation, and the gradient as well. We have just determined the gradient. Now, which point did we use here? We have used this point B, but there was just a mistake. This one, this is not supposed to be 1, but it's supposed to be positive. It's supposed to be +2, because now we have used this point B as for X and Y. All right. And from there, you then have actually it was supposed to be 2. It was supposed to be 2, not 1. And then this 2 transpose is going to be +2. Then now let us recalculate that equation. Here we have negative 2 over 8 plus 2. It gives us 7, not this one, but it gives us 7 over 4. It gives us 7 over 4, not 15 over 8. So there was just a mistake for that. Now let's proceed. P is -2 is to -4, Q is -4 is to +2, and R is 7 is to -1 are vertical of triangle PQR in a Cartesian plane as shown below. Theta is the angle of inclination of PQ. Prove that triangle PRQ is a right-angled triangle. Now let's see on how do we prove it that a triangle is a right-angled triangle. We are going to be calculating what the gradient of this line Q. We calculate the gradient of this line QP, and then multiply by the gradient of this line PR. And then if that gradient gives us -1, it shows that this line QP is perpendicular to line PR. And we know if two lines, they are perpendicular to each other, where they meet, they should form 90 degrees, meaning this is going to be the right angle triangle. Now let's prove it. You substitute the values, and then you press a calculator, and the answer that we have is -1. Therefore, the triangle PQR is a right angle triangle. All right. And then calculate the area of triangle PQR. Let's calculate the area, the distance of QP first, and the distance of PR. Let's determine the distance of QP first. Substitute, and the answer is 2 √10. So that is the side. The distance of this side is square root of, is 2 square root of 10. And then the distance PR, we substitute the value is what? Is 3 square root of what? Square root of 10. And then you can now write the formula for the distance. And then this is what we have in the base, and then multiply by the height. So the answer, the correct answer is 30 units squared. So that is the area for that triangle PQR. In the diagram below, a triangle ABC has a vertices A negative 6 is to 4, and then B 2 is to 2, and C negative 6, negative 2. In the Cartesian plane, the angle of inclination of BC is theta. Determine the gradient of AB. Let's determine the gradient of AB. It's very quite simple. Just substitute. Make sure that when you substitute the values, they are correct. And then now the gradient of that line is negative 1 over 4. Now determine the coordinate of D, the midpoint of AC. Let's determine the midpoint of AC. Then you just press your calculator, and the gradient, I mean the midpoint of AC, it gives us the point of D, which is negative 6 is to 1. That is correct. Thereafter, you move to, all right, we're still on the same question. Then now we have to determine the equation of a straight line, DB. Remember there is D here. So we need to calculate the equation of this line, DD. All right. Let me just fix this. All right. From B to D, somewhere here in between this line AC. And then let's see, first we need the gradient. Then we're going to be calculating the gradient of BD. And then we say YB is 2 minus 1, and then 2 minus 6. And then our gradient is 1 over 8. And then we decided to use point B, which is 2 is to 3. You can also use point D, and that one of negative 6 is to 1, still fine. And then you write the standard equation, then you substitute the values. And then from there, you're going to open your bracket with this 1 over 8. Then 1 over 8 times x is 1 over 8x. 1 over 8 times negative 2 is negative 1 over 4. And then this negative 2, when you transpose it to the right, give us positive 2. And then after pressing calculator, you then have the equation as y equals to 1 over 8x plus 7 over 4. We still same question, same scenario. Now we need to answer the following question. Calculate the distance of BC. We need the distance of BC. You write the correct formula for the distance. You then substitute correctly. You press your calculator. And then we have square root of 80, which is 4 square root of 5. That is the distance of BC. You can see everything is it's quite easy. You just need to know which formula to use. And then please, when you are starting substituting, make sure that you substitute very correctly, because one mistake, you're going to get everything wrong. All right, you must also be aware of the signs as well. The angle size theta there, we need this angle theta. Now first, for us to get the angle theta, we also say tan theta equals to gradient of BC. Let's determine the gradient of BC, and our gradient of BC is equals to 1 over 2, which is 4 over 4 over 8. And then you divide with tan, then theta equals to shift tan into 1 over 2. And then the angle that we are looking for there is 26,565 degrees. All right, we are done with the linear analytical geometry. We are now into a circle analytical geometry. And then for circle analytical geometry, we must be able to find the equation of a circle. That's number one. Of a semicircle in the form of x squared plus y squared equals to r squared. And then we have to determine the equation of a tangent to a given circle if the gradient of a point is given. All right, now let's see what are we going to be discussing under circle geometry. All right, in the diagram below, O, which is 0 is to 0, is the center of the circle with the equation x squared plus y squared equals to 5. We have the equation of that line, of that circle. A straight line, KL, with the equation of y equals to negative 2x plus 5 equals to 0, is the tangent to a circle at point L, and then LO is produced to M, and negative 3 is to 3 over 2. K is the y-intercept of the straight line, MK and LK, right? Now let's first determine the numerical value of T, meaning we are in need of this T. So how do we determine T? Since T, that point L, it is on this line KL, and we do have the equation of KL, which is this. Then what we can do, we just substitute that point L to the given equation, and we can see the x is T, the negative y is negative 1. Hence you see negative 1 here, and then T. From there you transpose, you divide with negative 2, and then the value for that T is positive is positive 2. Now you can also use the equation of the circle, which is x squared plus y squared minus 5, to get the value of T. You can substitute that point here, then you will be able to get the value of what? The value of T. All right, number 2, the coordinate of K. We can see the coordinate of K. That K is what? It's y-intercept. And then let's see if we can be able to do that. And then this what, remember when you are looking for y-intercept, you let x to be 0, hence you see 0 in a place of x. And then from there you transpose, then the answer is negative 5. And therefore the coordinates, okay, that's question what was supposed to write the coordinate of k, which is 0 is to negative 5. So we're supposed to write k is to negative 5. That is the coordinate. All right, that is the coordinate. You don't just leave your answer with that y value as negative 5, but you must write that point k to show those are the coordinates. All right. And then we have the same scenario and the same structure. So we just have to answer the following question. The equation of a straight line that is parallel to KL. There is a line which is parallel to KL and also passes through point M. Give the equation of that in the form of that, meaning there is a line passing through this point M, and then that line is parallel to this line KL. Now remember, when you have to calculate the equation of a straight line, you need two things. You need the gradient and the point. But now you can see this point, this line which is passing through M, we are in need of the equation of that line. And then since it's passing through M, then we're going to use that point M as a point, and then now we have to look for the gradient. But what we're going to do, the gradient of LK, we rewrite this one first. You remember, can you see from the scenario, it was y equals y minus 2x plus 5, and you need to rewrite in this form to make y the subject so that you can be able to take out the gradient. All right, and then the gradient of that is equals to 2. Therefore the gradient of the line is also 2 because it's parallel to LK, meaning the gradient of the line that we have to calculate the equation, it's also 2. Why? Because it's parallel to this line KL. Remember, if we have two lines which are parallel to each other, they are equal in terms of the gradient. You write the standard formula, you then substitute the values. Remember, you take point M and the gradient, which is 2. You substitute, you open a bracket with this positive 2, then it's going to give us 2x plus 6, then you transpose this one this side, so it's going to give us positive 3 over 2. Then from there you press your calculator, and the equation of that line is y equals to 2x plus 15 over 2. In the diagram below, O is the center of a circle. O is the center of a circle. And P and Q, 12:5, are points on the circumference of a circle. POQ is a straight line. The point R lies on the tangent to the circle at Q. Determine the equation of a circle. We need to determine the equation of a circle. Now let's first write the standard equation for circle, which is x squared plus y squared equals to r squared. Thereafter, you substitute the point on the circumference. Any point that you come across on the circumference of that circle, we are going to use it as x and y, and the only point that we are having is point Q, which is 12:5, and you see 12 there and then 5. You just press your calculator, you add, and then it gives us 169 equals to r squared. So there is no need to, once you reach this stage, there is no need for you to calculate the radius, because just having r squared then is fine, and therefore the equation of this circle is x squared plus y squared equals to 169. All right. And then number 2, determine the equation of a tangent RQ in the form of this y equals to mx plus c. We need to have the gradient and the point. You can see this on this line, we have the point already, which is 12:5, but the problem is the gradient. How are we going to obtain the gradient? Now, first, we are going to calculate the gradient of this line OQ, because we have 2 points. Remember, the coordinates of O is 0 to 0, of Q is 12:5. Then the gradient is 5:12. All right. And then we also know that if we have a line from center is perpendicular to the tangent, so it forms 90 degrees. So meaning the product of the gradient of these two lines, they must give us -1. Then use this formula, and then from there it's going to give us the gradient of that line, which we have to calculate the equation as -12/5. Then we are now having the gradient, we are also having a point. We can now calculate the equation. You substitute correctly, you then open your bracket with -12/5, and then it's going to give us -12/5x. Then you multiply this one as well, and then you take this 5, -5 to the right hand side is going to be positive. Then you add them together, they give us that equation. All right, we still have the same scenario, the same diagram. And we now have to answer the following question: determine the length of the radius of the circle. Remember earlier on, the first question, I think we have determined r squared as 169. Then now, how do we get the radius? Okay, there was just a mistake on this one. I don't know why we have used this. All right, let me just correct this. This is not correct. This is not correct. And then now remember, there was a question where we had to calculate the equation of this. Let me just see. In the diagram below, O is the center. If the center of a circle, and F, which is 10 to -4, is a point on the circle. H is the diameter of the circle, and then GH is the tangent to a circle. All right, now this is correct. We are told that that point F is the point on the circumference of a circle. Now this is how you should now determine. I think this question was not supposed to be 12:5, right? Yeah, that is the procedure to determine the radius, because we use this one from the scenario and they are saying the point f10 is to -4 is the point on the circle. All right, it's the point on the circle. So hence we use 10 and -4, and then after reaching this stage, you just put square root both sides, and then the radius is 2 square root of 29. And then the gradient of OH, the gradient of OH, H we have -10 is to 4, and then from there you then substitute the values. Coordinates of H is this one, and then O is 0 to 0, and then you just substitute, and the gradient is -2 is to 5. All right, thank you very much for being with me on this very interesting lesson. I hope whatever that we discussed today is going to help you, or is going to have an impact on you, and so that it prepare you for this coming final exam for technical mathematics. Let us make sure that we push and push and push. Like I said, that we should use the previous question paper so that we can get the style of question, and then you can get used to that. It's very, very important. And must also have the examination guideline for technical mathematics. It's also important. And then before I can leave, I just want to leave you with these words that says, study like there is no tomorrow, because if you keep putting off your studies for tomorrow, you'll probably be late. So let us start soon as now for revision, and revise more and more and more, and make sure that we answer relevant questions. We have questions so that you can be able to see which part you don't understand under technical mathematics, and so that you can challenge, or you can go straight to that challenge and deal with it. All right, thank you very much. Bye.